that's why I wanted to announce those. So if we are looking at this, just really quick, and then we will get to homework questions, because I want to look at those homework questions because you will see. So if I was looking at number 1, what would you tell me, Bryce, is my vertex? Negative 2, comma 0. And I want you to look at how this equation is written, right? It was x and it was plus 2, right, squared, and our vertex was at negative 2, 0, and my axis of symmetry is at x equals negative 2. If I'm looking at number 2, Grace, what would you tell me my vertex was in number 2?
I didn't get that.
Just looking right here, what is the solution or the vertex as you look at your graph? Did you not get yours back?
I got that back, but all my numbers were like off like 2 in my column.
Georgia.
4, number 2.
Mm-hmm.
1, 0.
1, 0. Notice that this was x minus 1 squared. Here it was x plus 2 squared, okay, where our vertex is. If we are looking down here, my vertex in this one, AJ, what'd you have? 10, 0. 10, 0 or 0, 10? 0, 10. Okay. 0, 10. And if we look at our equation, it had nothing in that parentheses squared, right? It just had a negative that told us the graph was going down. And then we had the plus 10, okay? So 0, 10. If we are looking at number 4, Kylie, where do we have our vertex?
2, 4.
2 and negative 4. And I want you to look at our equation. Our equation was x minus 2 squared, and then it was a minus 4. So when the number is outside of the square, what does that coordinate tell us in our vertex? This minus 4, this plus 10. It tells us our, which coordinate, x or y? What is this number telling us? The plus 10, the minus 4, the 0, the 0. If I was asking you to make a generalization, what could you tell me all the time, Grace?
Like how far up or down your vertex is going to move on the flat.
This number right here tells us how far we're moving up and down, that plus number. This is going to be key when we get into some of the later units with the graphing as we get ready for our test. So if it's written in this form. If it's not in standard form, this number, so if we are looking at the number inside with the x minus 2, this one was really, if we think of that, this is x plus 0 squared, right? Plus 10. This one was x plus 2. This one was x minus 1. How does that relate to our x coordinate? Tell your shoulder partner what you think. How this number in the parentheses is related to our x coordinate. Here it was minus 1 plus 1, plus 2 minus 2, plus 0, 0, minus 2, 2. Talk to your shoulder partner right now. How are those two related? So if you're going to generalize, the number outside that parenthesis always tells us to move our parabola up or down. The number inside the parenthesis with the x. Daniel, Ryan, what did you guys come up with? It moves on the x-axis. Is it always the same as this? No. It is always going to behave a what? In relation to the number that's inside here. It's always the opposite. If this is plus 2, this is going to be our x coordinate is at a negative 2. This is a minus 1, it's a plus 1. And that works all the time. So, looking at your homework, there were some questions from the worksheet, and then there was also some from the textbook. And my guess is that some of the ones in the workbook, if I am looking at those. So number 20 on this one. Number 20 said we have this circle, right? That's the one I'm looking at. Number 20 is telling us that we have a circular flower bed and the area. So this is on worksheet I4. And it says that the area of our circular flower bed is 85 meters squared. What is the radius? So we're trying to find our radius. And so that the largest circular bed is covered, round answer to the nearest 10th meter. So first off, area of a circle, pi radius squared is equal to our area, which means pi times radius squared has to be equal to 85. I want radius squared by itself. So on my calculator, I'm dividing both sides by pi. And if I do that, radius squared, what's nice about most of your scientific calculators is then to find the radius, right? If it was radius squared equals this, the radius is going to be equal to the square root of 85 divided by pi. You can put that whole thing underneath your square root when you're doing it on your calculator, so you can put square root, then you can put, it'll come up square root, you could put parenthesis 85 divided by pi and hit the equal, and we should have approximately rounded 5.2 meters. So you have to first get radius squared by itself, so radius squared was equal to 85 divided by pi. Then you're going to take the square root to finish that problem. Okay. Number 26. Got some fractions in it. You start off with this problem. 5a squared minus 125 equals 0. So the first thing we want to do is we want to say 5a squared is equal to a positive 1 over, it should be 125. I can't talk and write the same. So we should have now a positive 1 over 125. If I want to get rid of the 5, that's the same as dividing by 5 or multiplying by 1/5. The reason I want to multiply by 1/5 is I already have a fraction over here. So if I am looking at this, I now have a squared equals 125 times 5 gives us 625. All right, so is 625 a perfect square? So they ask us to put our answer, write your solution round to the nearest 10. So when you look at this, if I know a squared is equal to 1 over 625, a is equal to the positive and negative, two solutions, square root of 1 over 625. I'm going to put that in my calculator because it asked me for a decimal. I have a positive and negative 0.04. Anyone put it in yet? 0.4. When I look at an equation, on your little homework quiz today, I'm going to ask you how many solutions, what are the solutions, right? I'm going to give you something like this, or they won't be this hard, they're more like the earlier ones. I might give you a graph. If I give you this graph, how many solutions? 1, and it would be negative 2, 0. This one would have one solution, be 1, 0, right? This one would have two solutions. Can you tell me the two solutions without even knowing the equation? Yes, you should be able to look at the graph and say, oh, it looks like, and I don't know if this is right, but like 3 and negative 3, right? If I give you this one on the quiz, you tell me the solution is 0 and the solution is 4, right? That's all you're going to be asked to do on the homework quiz today. There'll also be one that is kind of like the beginning part of today's homework, that not like one of the area ones that you're looking at. Is 17, is that from the worksheet?
Yeah.
17 is from the worksheet? 17. 17 is almost exactly like 20. It's just a circle. You're going to divide first by pi and then take the square root. So 17 and 20 are the same types of problems because it's a circle area. Okay? 32. I think I'm going to leave 32 right now. 32, that one is in the textbook, right? 32 is what's the length of the square that equals 1. So if you are looking at a square, so this is like in your worksheet number 18, some of those.
It's a triangle.
Was it a triangle in 32? So in 32, if we are looking at that one in the workbook or in the book? Okay, I thought we were looking at 32 in the textbook. Okay, so 32 in the worksheet. What you're going to look at is how do you find area of a triangle? Area is equal to 1/2 base height. We know that this is 95 from our picture. And what is our base? 3x. And what is our height? 3x. How can I get rid of a half right away? I don't like it. How can I get rid of it? Multiply both sides by 2. I'm going to multiply by 2 over 1. Multiply 95 times 2 also. When I multiply 95 times 2, I get 190 equals 3 times 3 gives me 9x squared. Are you okay from here finishing? The question says find the value of x. You don't have to find the value of the side. You're going to divide both sides by 9 so that x squared is equal to. Then you're going to take to find x. It will be the positive square root of that. Round it. Okay. So we want to look at this week, big quiz on lessons I1 through I4 through I5 on Friday of this week. Oh, I know I'm gone for baseball. Thursday I'm gone for track in the afternoon. You want to make sure it is an excused absence that we make plans to make sure either you can take it before or take it afterwards. I'm okay if we end up doing it on Monday, but I just want you to kind of be aware of that we need to, that's kind of where we're going. So this week we really have I5 as the last new lesson. So again, we take a couple of days with it. We're working on some in the textbook tonight, then on the worksheet, and I kind of broken down where we don't do all of them. Studying for your quiz, we're going to have a review worksheet. There's one in the workbook. I have some of those Quizlets that you can go over. You can do the Pearson, but I do have a second sheet that we're going to be looking at. Then we have review from the textbook on Thursday. So some of you might feel that you could take it Thursday because you're going to be gone, and that would be fine. Going back to factoring right now, I want you to factor these two. The first one, you don't really need that AC method, right? This second one is where you might be taking 2 times -3, and you might have to break it down. So please start with factoring. Don't worry about your homework right now. I want these done. I don't want homework. I want you on your notes. This one right away, you should be able to tell me the 2 parentheses. X and X. But this one, my hint is you might want to go with a middle term, right? Something X. Remember when Mr. Lehman was teaching this? X squared minus 7x plus 10. Has to multiply 2, 10, and add to -7. What am I looking at? Someone raise your hand. What do I have for my factors? Sam? -2, -5. So if I check, right, by either using the FOIL or my middle terms, this gives me -2x, this is -5x, -2x, -5x does add to my middle term -7, and negative times negative gives me 5. Now when I look at this one, this is where I talk about finding, you might have to use that AC method. Remember when we multiplied? And we take our A, which is 2, and our C, which is -3, it multiplies to -6. So I need 2 numbers that add to -6, or multiply to -6 and add to 1. So when I rewrite this, I'm going to have what are going to be my 2 that I am looking at for my middle term. Bryce, I should have. Okay, so before I even get there, I might look and, oh, okay, I know it's 2 and 3, and I know, like here, I could go with a Is it gonna be a positive 2x or negative 2x? Negative 2x and a positive 3x. So if I'm looking at this, now I factor out my greatest common factor. Remember doing this? You guys did great on this test, so you might want to look back at that last unit. I factor out a 2x, right? What am I left with? X minus 2. What's my greatest common factor in the second two? 3. How about x minus 1? 3, and then I'm left with x minus 1. This kind of remind me of remembering. So what is my final answer up here? My final answer is, what do they both have in common? X minus 1. When I factored that out, I was left with a 2x plus 3. Okay? Questions? So, today we're using this factoring part, and a lot of yours are going to start off today with what's called the zero product property. Okay? So, when we come back from lunch, the key thing I want you to notice, two things, if multiplied equals 0, I know, it's so anxious when I say that. If one of them has to be 0 or the second one. So when you look at this, I know, focus up here, focus. X plus 3 times x plus 2 equals 0. What's really nice is you're going to put one of them equal to 0 or the other one. All right. So hard. So what this property says is that if two things multiplied together equal 0, either 5 has to equal 0, which is not going to be the case, right? Or g has to be equal to 0. So what do we know? We know g has to be 0. If x times y equals 0, that means we're going to put that x is equal to 0 or y is equal to 0. And if you think of if x is equal to 0, y could be any number, right? Y could be 10, it could be negative 10, it could be 20, it could be negative 745.2. If you take it times 0, you will get 0 for a solution. So what we're going to be doing is our equations are going to be, we have to factor them, and sometimes they're going to be in this factored form. So if we look at this, 3 can't be equal to 0, so we don't have to worry about that. So then we put k minus 1 equals 0. If k minus 1 equals 0, what do I have to do to solve for k, Noah? No. K minus 1 equals 0. Add 1, and we're done. And my answer would be, if k equals 1, that would be one of our roots or one of our solutions that we're going to be looking at. So if I have p plus 1 and r minus 4, and here we have two different variables, which usually in our case won't be the case, we're going to set each of these equal to 0. So please do that, and then right below, tell me what each one is equal to. So my two solutions would be p equals this, or r is equal to, Kaylin, one answer, p is equal to negative 1, and Sam, r equals 4. If r equals 4, it doesn't matter what p is, right? Because if I have 4 minus 4, the whole thing is going to be 0. So it doesn't matter what number this is, it's going to work. And if p happens to be negative 1, r can be any value, and it will make that a true statement, okay? So what you're going to be doing is using this zero product property. Is a lot of times you're going to have the two parentheses. Set each one equal to 0. So if you would, starting down here, set each of these equal to 0. So 2x plus 3 equals 0, x minus 4 equals 0. And it's always an or, because it could be one solution or it could be the other one. 7n minus 5 equals 0, and this is just going back to your basic solving of two-step equations. Addison, if we're going to start solving 2x plus 3 equals 0, what would you do first?
Subtract 3.
Subtract 3. So 2x equals negative 3, then what?
And divide by 2.
Then divide by 2. So I have negative 3 over 2. Could I rewrite that as negative 1.5 if I wanted to instead of 3/2? Same thing, right? And in this one, if I was solving, what is my solution as I'm looking at this one, Avery? And x equals 4. So if I were going to graph these two numbers on my graph, right? These are what these solutions are telling us. Negative 1.5, right? That's one solution. And over here at 4 is the other solution, right? So my parabola in this case probably was an upward parabola because it's, if I would multiply this out, it's going to be 2x squared. And so it would have been something like this, right? I don't know where this vertex is. We're not going to figure it out. You don't have to worry about that. All we are looking for is solving the equation. So in this next one, Ava, if I'm going to start solving, what do I need to do first? Add 5, so 7n equals 5. Last step, divide by 7. So n is 5/7. Or my other equation, if I'm looking, Lauren, what are you going to do next? Ooh, by 5, it should be 2. I know, I got the 5n and the 2 mixed around. All right. Lauren, how about this next one? Add 4. And for some of you, definitely show this add 4. Some of you are going to get to the point where you just go 5n equals 4, and n, Lauren, is equal to 4/5. Most common mistake is people will just sometimes go negative 4/5 because they'll take this number and just put it over 5. Remember, you have to set it equal to 0, so just be careful for that. Okay? So now you look at an equation like this, and this is where that factoring comes in as earlier. I'm not going to always give it to you in factored form. So first method, you can use square roots like we did in today's homework. If you don't have a middle term, you always want to use square roots. It's the easiest way. That only works so when you have x squared equals a number. If you don't, you could go to graphing. Sometimes graph paper is a hindrance. So today we look at this third method. You rewrite your equation in factored form and solve for the zeros. So this one, you don't even need AC. Multiplies to negative 14, adds to negative 5. Try and fill yours in right now. We got to have a minus and a plus, right? Because it has to multiply to a negative 14. Okay, what should be my minus? Multiplies to 14. What's your first thought when you think of multiplying to 14, besides 14 and 1? 7 and 2. So now it has to add to a negative 5, so which one is my negative? Negative 7, positive 2. So I'm going to go minus 7 plus 2. I am now using my rule that says if these two things equal 0, then m minus 7 must be equal to 0, or m plus 2 must equal 0. And now we're solving for m. So Daniel, when I solve for m is equal to 7, and in the second one. And I can write it this way. Remember how we wrote our solutions? X was plus and minus 4, or plus or minus. We can write it out like this. Or I would take m equals 7, or m equals negative 2. You can write it that way. It says to use this method, the equation must always be equal to 0. So if it's not equal to 0, you got to get it equal to 0. So the last one down here, you got to get it equal to 0. First one, I'm hoping you can try and factor this one on your own. Second one, do we have a greatest common factor? Remember when we did factoring? No. 2, 15, 18, so we have to take AC. What is my AC? 2 times 18. 2 times 18 gives me 36, and it has to add to negative 15. So I'm definitely doing this one with the 2a squared, with my 2a terms in the middle. 18 equals 0, and then I'm going to look for my greatest common factor, okay? So, negative 20 has to multiply and add to 1. Reese, what are you thinking? Multiply negative 20, add to 1. Okay, wait, don't do a plus. Just tell me what's going to multiply to negative 20. 5. Okay. 5, negative 4. So right away, this one, I don't have to break it down. I can go right away into my factors. P plus 5, right? P minus 4. If I check that, gives me negative 20, gives me a plus 1 for my middle term. I am now setting each one equal to 0 to solve. My two solutions when I look at this, AJ, should be yes. Did anyone figure out our 2 and 18, 36, that adds to negative 15 yet? What my two values? Sam, you got it? Negative 12 and negative 3. Negative 3. Adds up to give us our negative 15. Now, and it wouldn't matter which order we put them in. They do both have to be negative. So now we're going to factor out our greatest common factor. So, Sam, you want to keep going with it?
Not really.
Now, give the next step at least. You factored out 2 and A?
Yep.
Okay. So, Georgia, looking at the next half. We know this key thing has to be A minus 6. What'd you factor out? Negative 3. I don't care if you go plus negative 3 or just a minus 3. Then we are looking at what, Georgia? A minus 6. All right. Addison, you ready?
Yeah.
First parenthesis, you're going to put what?
What? I forgot how to do this.
No, you didn't.
Okay.
What do they have in common? What do you
Oh,
factor out?
A minus 6.
A minus 6. Left with?
Oh, 2A minus 3.
Yes. I just solve, Bryce. A is going to be equal to A minus 6 equals 0, right? 2A minus 3 equals 0. What is my A value is going to be equal to, Bryce? 6. No. Positive, right? First thing you have to do is add 3. So what he just did, that is the most common mistake, and I will have people do that all the time. And I'll have them say negative 3.5, because they look at this, negative 3 divided by 2. Remember, you have to set it equal to 0, get the variable by itself. So A is equal to 3 over 2. I would take 1.5. Now, what that means is if I plug in 6 up here, I should get 0, right? If I plug in A equals 6, so please on your calculator right now do this. Put in 2, put in 6 squared, minus 15 times 6 plus 18. And you are checking to see that you get 0. So all of these you can check. So when we go to take the quiz on this, the test on this, and you're like, I don't know if this worked out right. Anytime you get this solution, it has to make the equation equal 0. If you get that one to work, try 1.5. So the second time through, try it with 2 times 1.5 squared minus 15 times 1.5 plus 18. Did the first one give us 0? Yes. So try 1.5, plugging that in and just making sure. So anytime you do these, you can always check. And some people are like, oh, I don't know if I did it right. And you're looking at the answers. This is how you can check them, okay? Last one on this page before we go to that, we got to get it equal to 0, which means x squared plus 14x, and we are adding 49 to both sides equals 0. Anyone recognize this special trinomial? So remember those special cases? You had difference of squares, you had the perfect square. I love that look. That makes me so happy. All right, so I had some recognition. What do we know about 49? It's a what?
Perfect.
Perfect square. X squared is a perfect square. Can we write this as something squared equals 0? This is our a squared, right? Plus 2ab plus b squared. You recognizing that pattern? So when we did those and that recognition of that, this is key. That's why we did those and we kind of hit them hard. So what is it going to be looking like? It's going to look like x plus 7 squared. Now at the beginning of the unit today, we said if we had x plus 7 squared and we graphed that, where was the vertex? Anyone remember? My vertex is at what point? Anyone remember what it did for the vertex? Is it 7, 0, or negative 7, right? Because it's the opposite of this, right? So if I was going to graph this parabola over at negative 7, right? This is negative 7, 0. I've just graphed that point. How many solutions are there going to be? If I look at this graph, how many solutions? 1. But there's something squared. And someone said, well, what if I write it out like this? X plus 7 times x plus 7, because some of you might do that. If you set this first one equal to 0, right, you're going to get x equals negative 7, the vertex. Does it matter if I set it equal again, the other x plus 7? It's going to be the same, right? This is my solution. This happens to be my vertex, okay? So whereas these other ones, they weren't vertexes, kind of as you're looking at those. All right. So I think at this point, we are going to, instead of going through the rest of this, I want you to take out, we're going to take a look at your homework. And we will finish this one and take your quiz probably tomorrow. So tomorrow, we'll have your quiz on this. I want you to look right now at page 571. On page 571. You are looking at 9 to 35 odds. And as you do those, we won't hand this in tomorrow, but you should definitely be able to do all of them except like maybe some of those story problems. But even those, we can should kind of be able to take a look at. The key thing is that when you write equations, they always have to be equal to 0. So if it's not in standard form and it doesn't equal 0, you have to get it there. So as you take a look at your homework and you're starting off with number 9. Number 9, 11, 13, they give you the 2 parentheses, right? Copy the exact problem. So write the problem and then show solving. 9, 11, 13, I would not number your paper like this because you're going to put those 2 parentheses equal to 0. Then you're going to put what's in that first parenthesis, which was 4k plus 5. And you're going to solve and get what k equals. And then on this one, it was something like k plus 7. And you're going to get down here and tell me k equals. So you want to write out the problem and do this. When you get to number 15, that's where you have to start doing the factoring. So 15 gives us x squared plus 11x. Those of you that, which it shouldn't be many of you because you guys did great on that factoring test. You're now factoring equal to 0. Write the problem. Put each parenthesis equal to 0. Solve for your variable. That's what I need to see as you're doing this. The key thing is make sure your equation equals 0 before you start factoring. And some of the later problems, like starting at number 21 and 23 and 25 are not set up with it equal to 0. Do it equaling 0, okay, as you're looking at those. There's going to be a few of the questions that you're going to look at, like number 27, and they are talking about that blanket. When you do question 27, draw the picture. Don't just come in and say, Mrs. Thompson, I didn't get this one. So when I look at number 27 and it says that you have that you're knitting a blanket and you want the blanket to be 24 feet squared and the length of the blanket is to be 2 feet longer than the width. Well, when I look at 27 on your paper, I should see a blanket, right? And I should see the width and I should see the length to be, what did it say? 2 feet longer than the width. So that means this length has to be what? 2 feet longer than the width? Has to be what? Has to be W plus 2. And now what do I know is that length times width has to equal area. And before I can solve 27, my length, which is W plus 2, times my width, equals the area. I have to get it equal to 0 first. So I'm going to have to, whatever number is here, I have to subtract it, and I have to use distributive property, okay? And I know with spring sports, a lot of you are very busy with stuff. So just make sure that you are keeping up and coming in if it's before school, if it's after school, so that we don't get you behind on this stuff.
You want